everyone. Today we learned chapter 5, multiple integration, and section 5.5.1, double integrals over rectangular regions. Okay, so this is my best I can draw. I'm so bad with the drawing. Let's take a look this one. In calculus 1, we have a curve. Then we make a lot of rectangle, right? So what's the area of a rectangle is, we can say the height times width or length times width, right? So we found all the rectangle here. So height times width with the summation, because we add every rectangle, right? So we take the limit. So when n approach to positive infinity, right? So this is a Riemann sum, right? Riemann sum. So it's a mathematician from the Germany, right? And then we had from calculus 1, we can find area by using integral, right? Integration. So this summation and limit goes to the integral, right? So in that case, it's a definite integration because we need to find the area under the curve, right? So from A to B, and then f of x is the function, so there will be height, right? And then dx will be all the width, right? So we can find area from calculus 1, right? What about now in calculus 3? So we have a surface. So this is the function. There is the function, right? Okay, we have a surface. Now we have same like a Riemann sum. We make a rectangle here underneath the function, right? So this function, look, in x-axis we have a and b, and y-axis we have a c and d. So I made a note here. The region R, rectangular region, we make AB, and then this notation, can you see that? This notation with the Cartesian product of closed interval. Yeah. Now, XY is in two dimension. X is between A to B, and C is between C. Y is between C and D. Yeah, this reason. Make sense? Okay. Now, I told you earlier, it's the same concept with the Riemann sum from calculus 1. So we make all the little rectangle here, right? So we call this is we are going to use double Riemann sum. So let's take a look. So we have the function like earlier, right? So we take a look, f of x. Yeah. But in the case, we have two variables, right? So x and y. Then we're using two summation. So m for the x, m for y. Yeah. So what we do, double integration, since we have one integral finding area, right? Now we are finding volume. Then what's the formula for volume? So normally in rectangular shape, we are using height, length, width, right? Length, width, length, width, height, length, width, yeah, like a box, right? So here we go. So we have volume, the function is the height, and then dA, we denote like area. All right. So we understand what we are doing, right? Okay. Now, I made a nice note. All right. So we have iterated integral, means that integral first, then do another integral second. What does this mean? One integral at a time. So we integrate one, then we do another one later. Yeah. So the iterated integral looks like this. So we have the function and dy and dx. We have a double integral, right? That means we do the inner first. In that case, we integrate respect to y first because we can see the dy. And then we do integrate respect to x later, outer second. So in the region, the rectangular region, right? So we have x indicate AB, that is the first one. So we say that this is a Cartesian product of closed interval, right? So it's closed, right? Must be closed. Okay, now this is for x, this is second one is for y, right? So we are using that definite integration. Can you see that? Okay, let's take a look second one. So we have the function and then we have dx, dy means we need to integrate the inner first, which is respect to x first, and then later outer respect y secondly. Can you see the difference between? Yeah. Okay, very good. Now we have Fubini's theorem. So basically, Fubini's theorem, they're using the iterated integral. All right. So R rectangular region. So we have x, y. X is between A and B. Y is between C and D. Then we have integral notation. Then they are same. Yeah. Whether integrate dx first means that respect to first x, then y. If we integrate y first, respect to y first, then x, we get the same answer. All right? All right. Okay, let's take a look this one, this picture from your textbook. So let's take a look this one. So first one, this is a plane. Can you see that this plane like a front and back, right? So this is a parallel to the y-axis. So we can say that x equal to some constant for the equation. And then we called this is a YZ plane, right? So then we talk about this one when we had a partial derivative, right? So basically integrate in generally antiderivative over from the derivative, right? Antiderivative from the derivative. Yeah, antiderivative, right? So this is related with when we derivative y direction, how do we do? We treat x as a constant, right? So same as here, let's take a look. Integrate first with respect to y. That means we treat x as a constant. So let's take a look here. X is constant there, right? Yeah. So let's take a look second one. This plane, right? So this plane like this, like a insert like a in the wall, right? So this is parallel to the x-axis. Can you see that? Then we can say that y is constant. If y is constant, we called this is xz plane, right? Okay, then let's take a look second one. Integrating first with respect to x. This one, right? If we integrate respect to x, then we treat y as a constant because of this reason, right? Y is constant. Make sense to you? Okay. We have this problem. Let's do it. All right. Okay, so I added there by using the Fubini theorem. Okay, so this is Italian mathematician. So this theorem said that we can use either one, right? So let me put on this one here, copy. All right, if you want, I can do both way so that we can check the answer. All right, so let's do the first one. So we have, let's do that. Or the function then so let me do this one first, then this one later. We have y 0 to 1 and x 0 to 2 and the function which is x and dx dy, right? Okay, so we have to do inner first. All right, then integral of x, what do you get? X squared over 2, right? Good. And then we have to evaluate from 0 to 2. And then we have to have outside is dx, right? Okay. Now, we need to evaluate to x first. So we have 1/2, 2 squared minus 0, right? And then outer dy. Okay, so that will be from 0 to 1. So we have a 4 there. We simplify, so we have 2 dy. Okay, now we want to integrate respect to y. Then we get y, 2y. Yeah, so from 0 to 1. Okay, then what do you get? So we have a 2, 1 minus 0, which is 2. Yeah. Okay, let's do the other way. So let's do that. Copy. So we have, let me see, what's the respect to y? Y is 0, 1. So we have 0, 1 and x is 0, 2, right? 0, 2. And the function is x, dy, dx, yeah? Okay. we want to, let me write down this one first. This is the first. All right, so from 0 to 2, look, we want to, I have to be careful, not derivative, right? Integrate respect to y first. Okay, then x is a constant, then we will get xy, right? Because x is constant. All right, then we have to evaluate. So in that case, we get confused which one we have to evaluate, right? So we have to write down y equal to 0 to y equal to 1, right? All right, then from 0 to 2, we leave x outside because x is constant, right? Okay, then y 1 minus 0 dx. Yeah, then we get 1. So we can bring back the x dx. Yeah. Okay, now we want to integrate respect to x. So we get x squared over 2. Now we need to evaluate x equal to 0 to 2, right? So we have 1/2. We have 2 squared minus 0. So 4 and then 2 we can simplify, which is 2, right? So we get same answer. Can you see that? But which one is more easier? The first one was more easier, right? Yeah, because in that case, we have to treat x as a constant, so a little bit confused, right? Yeah. So Fubini's theorem said that either way we can change the order, we still get the same answer, right? By using what's the name? Iterated integral, right? Okay. Now let's do another example. Okay, so we have this problem. Let's take a look. So we want to find double integration xy minus 3xy to the second power dA. Okay. In general, if we have two terms or more terms, then there is more functions involved, right? Then in calculus 1, we split, remember? But then later on, we could just integrate, right? Since we had experience, let's just do in once. Yeah, we don't have to split two terms. Make sense? Okay. Now, the 4 minutes, correct, right? 4 minutes theorem said that we can integrate with respect to x first, then y second, or we do integrate with respect to y first, then x second, we get same answer, right? Just either one is more easier or more complicated, right? Okay, so let's do it. What do you want to do? X first or y first? Okay, x. Okay, now let's do it. So we want to, let me copy, paste. Oh my gosh, what's going on? Come on. All right, then look, we will use x first, then we have to denote that this is x first. because sometimes we get the same number. Yeah, even though we have dx, dy second, right? Yeah, we may get confused ourselves, right? All right. So from y equal to 1 to 2, ooh, we must say just 2 itself, y equal to 2. Yeah. All right. Then the function xy, oh, I need more space. Let's make xy minus 3xy to the second power. Okay, so we want to integrate this one first. All right, so y equal to 1 to y equal to 2. All right, the first term. Oh, so we treat y as constant. So first term, what do you get? Y is constant. So x squared over 2, but y is constant, so we keep the y, right? Okay. Now, second term, looking at this one, y is constant. So same x squared over 2, everything is constant, right? So we have negative 3y is constant over 2 x squared. And then we want to evaluate from 0 to 2 for the x and then dy. Is it clear to you? All right. Okay, so let's evaluate, right? We cannot simplify anything yet. Y over 2 for the first term, x squared, so we have 2 squared minus 3y squared over 2, x squared, which is 2 squared. And then I can just omit when x equal to 0, right? Because it's 0. All right, then let's just simplify. So we get 2, right? We get 2. So we will have 2y minus 6y squared dy. All right, now we want to integrate respect to y. So we have a 2y squared over 2 minus 6y to the third power over 3. And then we want to evaluate from y equal to 1 to the y equal to 2. So we get simplify 2. So we have y squared, so 2 squared minus 2 times 2 to the third power minus 1, right? So we have 1 minus 2 times 1, right? Okay, now, can you please do that? So we get negative 11, is it true? Yeah. Okay, so we talk about the volume, then why we get the negative? Think about the like a calculus one. When did we get the negative area, right? Yeah, curve is below to the x-axis, right? Yeah, we found area under the x-axis. That's the negative area. So it's not really physical. We find the volume, right? So if we have the surface, and especially here we talk about the rectangular region, right? So it's below z-axis. Yeah. So z-axis means z equal to 0, right? So we can have that. So in that case, it's xy plane. We know that, right? So let me write down. Negative. So, what's the best way, right? So here we go. I wrote down, we have a negative. Negative means this would indicate a region below xy plane, z equal to 0. Yeah, so basically below the z-axis. Yeah. Okay, so we have another question is here. All right, so we want to find the double integration, which is find the volume, right? So which one you want to integrate first? X first, okay? So then this one y equal to 0 to the 1 and x equal to 0 to the pi over 2. Now e to the y cosine x dx dy, right? Okay, now let me write down. We want to um, treat y as constant. Do first. Okay, so we want to integrate respect to x first. Okay, what's the integral of cosine then? Antiderivative. Yeah, so think about that. Antiderivative. Think something derivative makes a cosine, right? So sine. So because we get confused with negative or not, right? Yeah. So derivative of sine makes cosine, right? So we don't need a negative. So we have y equal to 0 to 1. And then y is constant, so we keep the constant. So e to the y sine x. And then we do evaluate from x equal to 0 to pi over 2 and dy, right? Okay. We have y equal to 0 to 1. E to the y function is, oh, it's not a function. It's a constant. So let's take out, right? Okay, now sine pi over 2 minus sine 0. And later on, with the integrate respect to y, right? Okay, sine pi over 2, what do you get? It's 1, sine 0 is 0, right? So, note. Sine pi over 2 equal to 1, sine 0 equal to 0. Then we get just 1, which is e to the y, right? All right, now we want to integrate to respect to y. Then just itself, right? So e to the y and y equal to 0 to the 1, evaluate. So e to the 1 minus e to the 0. And we have e to the 1 minus 1. Now let me just take out the first power. Yeah. You guys okay with this? All right. Okay, so we have another problem in two different ways. So means that we had experience in the first example, right? So we do integrate respect to x, then y, and also we do integrate respect to y, then x. Yeah. So we do two different ways. We're gonna do that. All right. So what do you want? X first? Okay, that's fine. So let me make that. Copy. And then x first, right? So y equal to 0 to 3. X equal to 0 to 2. And then function 3x squared minus y. You said x first, then y, right? All right. Okay, so let me write down the first. Treat y as constant. All right, so we have y equal to 0 to 3. All right. The first term, we do integrate with respect to x. What do you get? So 3x to the third power over 3. Very good. Okay. Second term, we want to be careful. Integrate to respect x. But y is constant. Then we keep the constant, right? So we keep the constant. Then what? X. Very good. Now we need to evaluate from x equal to 0 to 2. And then dy later on. So we have y equal to 0 to the 3. Okay, we can simplify now. 2 to the third power minus y 2. Yeah. And minus 0, 0. Yeah, locally 0, 0. So we don't have to do that. All right. And then dy. Yeah. Okay. So there will be y equal to 0 to 3, 8 minus 2y dy. Yeah. Okay. Now we need to integrate to respect to y, right? So the first term, 8y minus second term, 2y squared over 2. Then evaluate from 0 to 3. So 8y, we need to evaluate. So we will get 3 minus 3 squared. And then second one is 0, right? Okay. Now, can you please calculate 15? Good. All right. So we did this one. Integrate respect x first, then y second. Let's do the other way, right? All right. I need a number. Can I using this one and then change it a little bit? Oh, I need this one. Yeah. Copy. Okay, let me change that. Y second, right? So y second. And y. This one I have to erase everything. Okay, let me do by myself. Pause. Okay, so I wrote down. So we want to integrate with respect to y, then treat x as constant. Okay, let's do it. So x equal to 0 to 2. X is constant, so we keep that constant. And we are constant 3. Then we need to integrate with respect to y. So we get y, right? Good. Minus second term. We know how to do it. Integrate with respect to y, so y squared over 2, right? Oh, in evaluating. So y equal to 0 to y equal to 3. All right. Now, from x equal to 0 to x equal to 2, we need to evaluate. So 3x squared, y equal to 3, minus 3 squared over 2. Locally, other term is 0. So we get 9x squared minus 9 over 2, right? Okay, now we can do straightforward, right? So we want to integrate to respect to x. So 9x to the third power over 3 minus 9 over 2. We need to evaluate from x equal to 0 to 2, right? Okay, so simplify 3 2 cube minus 9 over 2. Then, oh, wait a minute. I made a mistake. Yeah. So we have to have x there. Look. So we want to integrate respect x. Yeah. Good thing I cut up right now, right? Then we have to have x. All right, then we will get the 2 then. And locally other term is 0, right? Okay. We can simplify 2. What do you get? 15. Very good. So do we get the same answer? 15? Yes, we had 15 earlier. Now we have also 15, right? So we can conclude. What's the function? So let me do this function. I don't remember. Okay, let me write down. Okay, so I wrote down here the same answer. Okay, next we have a definition here. Okay, so this definition said that the area of a region R is given by, we can use double integration. So we said earlier, what's a double integration for? So when we find the volume, we are using double integration, right? But then in that case, we can find the area. We can use double integration as well, but it must be, the function is the constant function, which is 1, right? So 1, yeah. All right. Let's understand this one, how we find the area, right? So this is the problem. So we have this region, x is between 0 and 3, y is between 0 and 2. So we want to find the area, right? By using double integration. And they say that by integrating 1 over region R, right? So let's just do it. So we have R, the rectangular region, and then 1 dA equal to integral. What do you want to do first? Okay, x first, okay? So you have a habit, right? X first. All right. So y equal to from 0 to 2, and x equal to 0 to 3, and then 1, and we want to integrate. I have to be careful, right? Okay, so we want to integrate this one first. All right, so what do you get then? So we have x, right? From, we want to evaluate 0 to 3. Okay. Oh, this is the last one. Last problem. So x equal to 3. So 3 minus 0 is 3. And we want to integrate with respect to y. Then we have 3y. And then evaluate from y equal to 0 to 2. So we have a 3 times 2 minus 0, which is 2, right? Which is 6. Yeah? Can you see that? This is the length. We can see that this is the length. This is the width. Yeah. Same as here, length, width. So 3 times 2, which is 6. Yeah. That's why we say that if we have the function has 1, we can find the area, not the volume. Make sense? All right. Any question? This is the last example in this section. So we keep continue next time. All right. Thank you for watching. Bye.